Welcome to the theoretical lecture on the Rhombencephalon. I've been sick lately, but as a matter of fact, this is irrelevant to today's subject. Nevertheless, I hope you can forgive me. Let's start about the many parts which make up the mesencephalon. First of all, we have the isthmus of Rhombencephalon, the pons, and the cerebellum. The isthmus of the Rhombencephalon, also known as the hindbrain, forms a dorsal border between the midbrain and the rhombencephalon. The trochlear nerve (CNIV) lies within this part. The isthmus has three elements: the superior medullary vellum, which is a sheet of white matter, pia and ependyma; the superior cerebellar peduncle, which joins the cerebellum with help of the midbrain red nucleus and the triangle of lateral lemniscus. Then we have the pons and the midcerebellar peduncle, which are divided by the arbitrary line of the trigeminal nerve, which marks this border between midcerebellar peduncle and the pons. And there's a bulbopondine sulcus, which separates the pons and the medulla oblongata. The pons consist of the longitudinal triodes, the tectum of pons consisting anterior, superior, medullary vellum, tegmentum, and basis. The peduncular triodes, three paired peduncles, superior, middle, and inferior, which attach to the cerebellum to the pons. There's the motor cranial nerve triodes, CN5, CN6, and CN7. Then the sensory cranial nerve triodes, cochlear vestibular nuclei of CNV8. Then there's the sensory nucleus of CN5, trigeminal. The pons has two surfaces. Anteriorly, it has the base of the pons with the basilar sulcus, with the basilar artery, longitudinal pontine fibers, the corticospinal fibers, part of the pyramidal tract, running to the spinal cord, corticonuclear bulbar fibers, part of the pyramidal tracts running to motor nuclei of the cranial nerves, corticoreticular fibers passing from pallium to the reticular formation, corticopontine fibers passing from the frontal, occipital, and temporal lobes to pontine nuclei. Then there's the transverse pontine fibers of the cerebropontocerebellar tract, with the pontocerebellar fibers which pass to midcerebellar peduncles. Pontine nuclei with the anterior nucleus, lateral nucleus, medial nucleus, paramedial nucleus, posterior nucleus, posterior lateral nucleus, and posterior medial nucleus. Posteriorly, we got the superior part of the rhomboid fossa, which is also the floor of the fourth ventricle, which we come to later. And tegmentum of pons include the trapezoid body, which forms the auditory pathway with the anterior and posterior trapezoid body nuclei. The median lemniscus, spinal lemniscus, trigeminal lemniscus, centrigrade substance, lateral lemniscus, nuclei of cranial nerve CNV2, CNV3. The reticular formation, a combination of the small nuclei, concentrated with the integration of visceral and muscular functions. There's a small graph where we see the exact position and loci of the cranial nerves. However, we should only focus on theoretically now. Maybe you can pause if you're highly interested. We come to the cerebellum with the located posterior cranial fossa above the fourth ventricle. It has two margins, anterior margin, anterior incisor, posterior margin, posterior incisor, lateral angle which joins the anterior and posterior margins. It has two main parts: vermis, centrally located, and the hemispheres of the cerebellum, which are lateral to it. There we see, like on the image, we got first of all primary fissure, horizontal fissure, then most inferiorly we got posterior lateral fissure. It is part of the motor system responsible for unconscious coordination and fine control of muscle actions. It cannot initiate conscious movements by itself, and it communicates with other structures through the superior rostral cerebellar peduncle It's mostly efferent from deep cerebral nuclei projecting to thalamus and red nucleus. They cross in vicusation of the superior cerebral peduncle. The efferents are ventral spinal cerebellar tract. The middle pontine cerebral peduncle, entirely efferent from pons that carry pontocerebellar input. Inferior caudal cerebral peduncle, mostly afferents from spinal cord, with the exception being vestibular cerebellum. Fibers are going to vestibular nuclei. It has several lobes. Anterior lobe from superior medullary velum to the primary fissure. Posterior lobe from the primary fissure to posterior lateral fissure. Flocculonodular lobe, which is the combination of the nodule and the flocculus. It's also divided into tunnel structure consisting of the white matter, medullary cortex, gray matter, two parts cerebral cortex, three layers, molecular layer, ganglionar layer, granular layer, cerebral nuclei. And we see like on the left two subdivisions of cerebellum, vermis, same level hemispherium cerebellar, hemispheres, superior surface, lingula, vinculum, central lobule, ring of central lobule, common, conjugular lobule, primary fissure, declive, simple lobule, folium superior pseudolobule, horizontal fissure, inferior surface, cuboformis, inferior pseudolobule, pyramidal bivental lobule, uvula tonsil cerebellum, posterior lateral fissure, nodule, flocculus. Then we have the nuclei, the dentate nucleus, or nucleus lateralis cerebelli. It is the largest, most laterally to cerebral nuclei. It is tooth-like and it has a hilum. There's the emboliform, globose, and fastigial, which originates due to its location near the fastigium of the fourth ventricle. Then the classification of the phylogenetic and ontogenetic development. The archicerebellum or flocculonodular lobe, functionally vestibular cerebellum, is responsible for the maintenance of equilibrium, posture, balance. Its deficit syndromes include vertigo, nystagmus, twinkle, stance, and gait ataxia, vomiting. Paleocerebellum is formed by anterior lobe of cerebellum, the vermis and medial part of posterior lobe, functionally the spinal cerebellum, responsible for regulation of muscle tone. Deficit syndromes include ataxia or lower limb mainly, oculomotor dysfunction, speech disorder, assynergy of speech muscles. Neocerebellum is formed by the lateral part of posterior lobe. Functionally it is the pontocerebellum, responsible for skilled movements. Deficit syndromes are following: dysmetria, hypermetria, positive rebound, intention tremor, nystagmus, decreased muscle tone. There are the following connections. First of all, we have the afferent connections with the inferior cerebral peduncle, which contains both afferent and efferent fibers. First, we have the restiform body. It has a posterior or dorsal spinal cerebellar tract. It is ipsilateral. Ipsilateral means its same action has the conflict on the same side. It's the reverse, vice versa of the ipsilateral and unilateral. It happens on the same side as the lesion, for example. The posterior thoracic nucleus to vermis close to anterior lobe and pyramid close to posterior lobe of cerebellum. It relays proprioception. Now, what is proprioception? It's basically time you, with your muscles, you need to engage in a certain activity, and the continuous sensation from lower limb. The craniocerebellar tract, again, it's ipsilateral, so it is most logical. It happens on the same. The tract is located on the same site where the action is being taken. The afferent pathway happens between the nucleus cuneatus and the posterior part of anterior lobe of cerebellum. relaying proprioception again a cognitive sensation from upper limb. Function corresponds to posterior spinocerebellar tract. The lever cerebellar tract from the inferior olivary nucleus, receiving sensory motor inputs and large contralateral projection from the cerebellum as well. And there is also an arcuocerebellar tract, reticulocerebellar tract, geminocerebellar tract. And then we come already to the juxtarestiform body. With the vestibulocerebellar tract, primary vestibular fibers, and the middocerebellar peduncle, containing only the sensory afferent fibers. With the pontocerebellar tract, corticopontocerebellar fibers, reticulocerebellar fibers. Then there's the superior cerebral peduncle, containing mostly efferent fibers, motor fibers from cerebellar nuclei. There's the anterior spinocerebellar tract relaying proprioception, for example, the musculospinal tendon receptors from the dorsal root ganglion lower limb trunk. They cross locally and then recross in pons to return to the ipsilateral side. Terminate in vermis and intermediate part of anterior lobe of cerebellum. You also got some minor fibers like cerebella, raphocerebella, rubricerebella, hypothalamocerebella, tectocerebella. Now we come to the majority of efferent connections. The superior cerebellar peduncle, cerebellothalamic fibers, dentate nucleus, embryoniform nucleus, and globulus nucleus. The VPLO, VLCL, cerebellar fibers, the red nucleus, mesencephalon, from nucleus interpositus and dentate nucleus, the scanning portion of uncinate fasciculus, and the superior cerebellar reticular tract, the reticular formation of mesencephalon, pons, medulla oblongata, the inferior cerebellar peduncle with its cerebellobulbar tract, starting within the fastidial nucleus and archicerebellum. Its fibers pass partially with vestibulocerebellar tract as the uncinate fasciculus. They all end in the vestibular nuclei as cerebellar vestibular tract, and the nuclei of medulla oblongata reticular formation is the inferior cerebellar reticular tract. You also have, my mistake, one second kids. You also have several olivocerebellar connections like the caudal portion of medial and dorsal cerebellar nucleus with its vermis of cerebellar cortex, vestibular nucleus, its rostral portion, and the dorsal accessory olivary nucleus, paravermal region, C1, C2, C3 nucleus interpositus, and the principal inferior olivary nucleus, cerebellar hemisphere D1, D2, dentate nucleus. For God's sake. Blimey. Okay. Current slide. Now, the functions. We have the maintenance of equilibrium. It's characterized by the unsteady walking and swaying when staying balance, posture, eye movement. And all signs give the lesion of the vestibulocerebellum, including flocculus, nodulus, posterior part of vermis. The second function is coordination of half-automatic movement of walking and posture maintenance. And lesion would include assynergy, the loss of coordination. There's the adjustment of muscle tone, motor leaning, motor skills, cognitive function, unilateral lesions of the cerebellum, leading to, now we've already been trapped in the syndromes, leading to motor disabilities. It's ipsilateral to the side of its lesion. And ataxia, loss of the coordinating muscular contractions, required for production of smooth movements, which we call hypotonia. So it's below what we would expect as normal. And the alcohol intoxication can mimic such syndrome, cerebellar ataxia. Yeah, the ataxia, as we've already touched upon, it's the uncoordination of movements. There are like several types. The truncal ataxia, when patients can't sit quietly, like me right now. Upright is distinguished from another type, the gait ataxia, with impaired limb movements, unsteady gait, and inebriation. Normally, a patient would stand with legs spread apart and places his hand on the wall for stability. Synergy is the lack of coordination between different muscle groups. Dysmetria, an ability to place an extremity at a precise point in space, for example, touch the finger to the nose. Dysdiadochonesia or ideodochonesia is an ability to make or difficulty in making successive and rapid alternating movements. It's also known as the ataxia of gait, with a tendency to fall towards the side of the lesion. The tension tremor, it's involuntary, arising when voluntary movements are attempted. Hypotonia, diminished muscle tone. Nystagmus, rhythmic oscillations of the elbows. Then we got the archicerebellar lesion, medulloblastoma, paleocerebellar lesion, gait disturbance, neocerebellar lesion, hypotonia, ataxia, tremor. The cerebellar hemisphere syndrome, ataxia and hypotonia of the ipsilateral extremities, anterior vermis syndrome, ataxia of the legs and trunk during walking, partially or no involvement of the upper extremities, speech or eye muscles, especially like in chronic alcoholic patient, flocculonodular lobe or posterior vermis syndrome, ataxia of the trunk, often nystagmus, pancerebellar syndrome, bilateral ataxia, dysarthria, nystagmus, hypotonia of all voluntary muscles. Now we come to the last column, the medulla oblongata, also known as the mesencephalon or bulbous anterior surface. It extends from the pons to perimeter decusations, and on the posterior side we can find these surfaces. First of all, the ventral surface with the anterior median fissure continuous with the spinal cord. Anterior median fissure of the medulla oblongata and spinal cord is separated by perimeter decusation, crossing of the corticospinal tracts, with the pyramid being the elevation of its track. Laterally located with the anterior lateral sulcus where CNX2 exits. It's olive. There is a prominence produced by the nuclei below and located between outlets of CNX and CNX2. The inferior part of olive is covered by the external arcuate fibers. Dorsal surface includes superior medial or inferior part of rhomboid fossa. Inferior lateral part including posterior median sulcus, posterior groove, the negrossi fasciculus, medial part of posterior funiculus, lower part half of the body with termination called the negrossi tubercle, which is the swelling of the nucleus gracilis. Then there's the cunate fasciculus, lateral part of posterior funiculus, upper half of the body, termination being cunate tubercle. Posterior lateral sulcus is a group with outlets for CNIX, CNX, and cranial part of CNXI, reaching to lateral recess of fourth ventricle. Tuberous cinereum, with the spinal nucleus of trigeminal nerve, located laterally to cunate tubercle. Horizontal cross section, we can distinguish two other parts, the olivary or superior part, including olivary nuclei, inferior olivary nucleus and accessory olivary nuclei. I mean, you can read it yourself, but vestibular nuclei, cochlear nuclei, accessory nuclei, spinal meniscus, centric subcentric formation. and the infra-olivary part. With olivary superior, including the olivary nuclei, infra-olivary includes the middle sensory decussation, decussation menisci, inferior motor decussation, pyramidal decussation, biggest nucleus, connate nucleus, gracis nucleus, nuclear cranial nerves, centrifugal substance, reticular formation. And now what's important is we have an inferior olivary nucleus, main olivary nucleus beneath the olive, including hilum of inferior olivary nucleus, open with sac-like olivary nucleus facing towards medial direction. It is connected to the motor coordination to the cerebellum and is the single source of ascending fibers to the cerebellum. Axons arising from cells in inferior olive cross enter this peduncle to reach a contralateral cerebellar cortex nucleus. See severity of motor inputs, and a lesion to the inferior nucleus results in motor discoordination of the contralateral arm and leg. A lesion at the cerebella results in motor discoordination of ipsilateral modes. Now, the nucleus ambiguus, also a motor nucleus of CNX, IX, and cranial portion CNXI, located after the olive. It is connected with the motor innervation of the ipsilateral muscles of the soft palate, pharynx, larynx, and upper esophagus. Axons of the motor neurons and nucleus ambiguus coast with these three nerves to innervate striated muscles. A lesion results in atrophy, low motor neurons, and paralysis of muscles, producing nasal speech dysphagia, dysphonia, and a deviation of the uvula towards a contralateral side. There is no problem with the sternocleidomastoid and trapezius because it is only a cranial portion of CNXI that is within the lesion and located at the spinal cord. Then, excuse me, there's also the Christian nucleus and the connate nucleus. You should view them as brothers because they are connected with discriminative touch, conscious proprioception, vibration sense from the leg, trunk, and arm. The central process of the dorsal root neurons T7 and below scan ipsilateral the fasciculus gracilis to reach the nucleus gracilis in the cauda meduloblongata. Processes of the dorsal root ganglion T6 and above scanned in the ipsilateral fasciculus conatus and then nucleus conatus. Axons from cells in both nuclei, they pass ventrally as internal arcuate fibers. Across the midline and form the medial lemniscus. The medial lemniscus scans to ventral posterior lateral nuclei to the thalamus, VPL, and they project to the somatosensory cortex. A lesion at fasciculus gracilis, nucleus gracilis cuneatus, and nucleus cuneatus result in ipsilat deficits at two-point discrimination, the vibration sense and conscious proprioception, from leg and arm. The lesion in the medial lemniscus results in contralateral deficits. Lesions in the internal arcuate fibers, before they even cross the midline, result in ipsilateral deficits. And the lesion of the crossing fibers from both sides naturally cause bilateral deficits. Then there's also a reticular formation. It is ill-defined, we don't know much about the system, with scattered neurons, intermingled fibers running longitudinally, and a neck mixture of gray and white matter of midbrain, pons, medulla oblongata, and spinal cord. We got several lemnisci. The lateral lemniscus connects trapezoid body, superior olive, with the inferior colliculus. Its function is preserved through the auditory pathway. As the medial lemniscus connects nucleus cuneatum and gracilis with thalamus. Its functions touch, conscious proprioception, trunk, and limbs. Spinal lemniscus connects lateral anterior spinal thalamic tract. Its functions pain pathway for trunk and limbs. Trigeminal lemniscus, CN5, or CNV, connects sensory trigeminal nuclei with thalamus, its function being sensory pathway of the head. Now we have the last column, the fourth ventricle. It is dorsal to the pons and is currently part of the medulla oblongata ventricular cerebellum, consisting of two parts. First we have the floor, it's the rhomboid fossa. It's diamond shaped, divided into two parts by the stria medullaris. Rostral part has medial eminence, elevation located between sulcus limitans, median sulcus, fascia colliculus, bulge produced by the internal general of CNV2, nucleus CNV1. Upper part is sulcus limiting, which is shallow groove or limitans, sulcus limitans, located to the medial eminence. Then there's locus ceruleus, shallow furrow, inferiorly extending to the mesencephalic aqueduct to the fovea superior, laterally to the fascia colliculus. Caudal part has hypoglossal triangle, gate between sulcus limitans and median sulcus. Vajra triangle, inferior to hypoglossal triangle. Funiculus separans, with both hypoglossal and vajra triangle. The fovea inferior, pit which also lies at the funiculus separans. The median sulcus divides the rhomboid fossa into the left trigon and right trigon, divided by the sulcus limitans into the vestibular triangle. In its lateral part and its medial part has the medial eminence, divided again by the stria medullaris and fascia colliculus above, hypoglossal triangle below. Roof of fastigium is superior part with left and right superior cerebellar peduncle. Then superior medullary velum between these peduncles, the inferior part, including nodal flocus inferior medullary velum. It has three openings, most importantly the lateral aperture, located near the end of the lateral recesses, the median aperture, which is above the orbex and opens to cerebello-medullary cistern. For these three apertures, the cerebrospinal fluid leaves the ventricular system and enters the subarachnoid space. We got focus on nuclei of CN5 to CNX2, located on the floor of the fourth ventricle according to the following order. First we got the motor neurons. The nucleus of the abducens nerve is on the level fascia colliculus, and the nucleus hypoglossal nerve in its posterior medial column. In its anterior lateral column we got the nucleus ambiguus in the medulla oblongata, facial motor nucleus, trigeminal motor nucleus, both in the pons. Then the parasympathetic nuclei in the superior salvatory nucleus, the pons for CNV2, inferior salvatory nucleus, medulla oblongata for CNIX, and dorsal motor nucleus of vagus. We also have, interestingly enough, a structure called area postrema on the roof of fourth ventricle at the level of the orbix. It is a chemoreceptor, trigger zone, also known as the vomiting emetic center, which serves as a protective function by reflex, eliciting emesis. It's the medical term for vomit, via connections with hypothalamus and reticular formation. Coordinates neurons sensitive to a wide range of toxic substances. We also have a nuclei of sensory functions, somatosensory, nuclei of the trigeminal nerve, nucleus spinal tract, CNV special sensory, cochlear nuclei, vestibular nuclei, parasympathetic afferents, and the nuclei of the solitary tract, including CNV2, IX, and X. And here you got a list of what we have included in the roof of fourth ventricle and the flow of the fourth ventricle. If you want to pause the video now, I will not read this out loud now. There's also the cerebrospinal fluid and subarachnoid space. And most importantly, we have, well, let me just tell you, there's following cistern, arachnoid cisterns, the cerebello-medullary cistern, pontine cistern, interpeduncular cistern, lumbar cistern, and the cerebrospinal fluid is, its secretions are produced within the cortexes of all the ventricles, lateral, third, fourth, and the reabsorption takes place by the arachnoid granulations. Circulation is according to this graph on the left. Just first, second ventricle, lateral ventricle, goes to interventricular foramina, to third ventricle, cerebral aqueduct, fourth ventricle, the aperture and median aperture of the fourth ventricle, subarachnoid space, arachnoid villi, superior surgery sinus, or dura mater. And that was basically all, folks. Hope you made all notes and learned a bunch of great stuff. See you next time.